the client ID in the code or the group ID. Consumer, I think it's a best practice to run the consumers with a group ID. It's just a string. It's just one line in your code where you just set the group ID and give it a whatever name you want, because then you can scale that consumer very easily by adding other consumers with the same group ID, and then they will work together, discover each other, and process your data in parallel. So it's a good thing for the Kafka consumer to run it with the group ID. But if you are writing code and you have in your producer and you want to create a client ID, that is something that is optional, but it's really useful to have for login purposes. And so, but it's still also just a string that you can set. Awesome. Hey, welcome back, guys. Did you guys have a great lunch? I'm looking into chat. Yes, excellent. Thank you, Sherlyn. Thank you, Martin. Okay, excellent. I didn't know if I told you guys this, but I have been to Singapore probably 3 times over the last maybe 6 years. When I worked for Cloudera, I was sent to Singapore, I think once or twice, and then for Confluent, I was also sent there one time. Very beautiful city, very nice place, it's an amazing city, and I love the food. Ooh, that is the number one thing. I would go back to Singapore just for the food. So, yes, it's I really enjoy the food. And the chefs, the hotel that I stayed in was not the best hotel, but the food was also very great, and they took such pride in preparing the dishes, and everything was so good. And then going around the city also was amazing in the market, trying the different foods. So I tell anyone I would go back to Singapore if no, for nothing else, just for the food. So you guys are great city. Okay, so let's get started. Welcome back, and good to have you guys back. So this is this is the second to the last chapter. Then we have a short chapter, which is 15 minutes about Confluent Cloud, but we are in a good space to continue to do this. And then I will have a summary at the end where I will take you guys to look at some APIs and the source code and stuff like that. So let's just get started with this one. Design decisions. So when we talk about, there's a lot of things that I think to be a good developer, people need to, number one, you have to really learn to code a little bit more, or just practice and study data structures and those kinds of algorithms and stuff. But when you're working in companies, it's good to understand a little bit about architecture, because you see, some people wonder, why is architecture important? Now, we don't talk about architecture in this class, but I just tell you as a developer, it's good to know. Because imagine if you have a whole bunch of people building a house, and you just give them all, okay, go ahead, and you don't give them a plan, for what they need to do. I don't know how well that house is going to turn out. So if you think about writing software, right, you have a bunch of talented developers, but they still need to have this big picture, sort of like the plan and design principles and stuff like that, right? So when we talk about coding, I think if you have a chance, take some, there's a lot of good training out there. Look at a little bit of architecture principles, like how you design code and layers, and like solid principles, and talk about understand the functional and non-functional requirements of stuff like that. Those are really good things to tie in. And the reason I say that is because it ties into the big picture of the business and why you're creating the software in the first place. This chapter has nothing to do with that. I just wanted to say that before we even start this chapter. But in this chapter, we're going to talk about some of the design decisions you can make when you're dealing with Kafka, right? Like, how do we avoid large message sizes? Because in Kafka, if you're running in Confluent Cloud, we say, yes, this is great. We customize it so we can go from 2 megabytes, I think, to 8 megabytes. And I think it's maybe even increasing because our environment is optimized for that. But in Kafka itself, Apache Kafka, you'll see that we try by default, we tell everyone to say, look, try to avoid going larger than 1 megabyte message size. And we'll talk about some of those. And then when do you use KSQLDB versus K-streams? And when do you use SMTs, single message transforms, versus, doing your transformation with K-streams or Kafka streams? I mean, K-streams or KSQLDB. And then what's the trade-off between processing guarantees? We are going to talk about some of those features in this chapter. So let's look at this. Starting with the first one. So what could possibly go wrong? Now, this is not saying that this will happen in Kafka, but this is saying, look, there are some possibilities of things that could happen, things that could go wrong if you don't have the right configuration setting. For example, this one, cross-zone consumer costs. Like if you set up a consumers and your consumers, let's say you have availability zone in the east and then the west, and think about it this way. Let's say this one is West Coast here, East Coast here, and there's a broker here, there's a broker here, and let's say this is another central area here. But remember, if the leader is in this, the leader is for partition is in this location on the west, and this is the east, and this is central, I would say. If I'm a consumer, and if I need to go to the leader, all the way to the leader, this is expensive, going from the East Coast all the way to this. So that's pretty expensive. That's why it's costly, right? And it would be better if I could go to a follower in these zones. But in previous releases of Kafka, consumers had no way to access the followers. But as of Kafka 2.4, Apache Kafka 2.4, and which is Confluent Platform 5.4, as of these releases, the consumer has the ability to fetch from a follower. So the consumer now has the ability to fetch from the follower. Because remember, before we told you that producers and consumers only communicate with the leaders. That means the broker that is the leader for a partition. They only communicate with this broker that is the leader for the partition. But now, as of this Kafka version, we allow the consumer to be able to communicate with the broker in a different location. Now, to be able to do this, all of these brokers need to have this property called the broker.rack property, right? And the brokers need to know, in other words, imagine that you are in the data center and you have racks. Of course, we'll see that this apply across availability zones. But if I have a rack here, and I don't want to ever have a situation where I put all my brokers in the same rack. Because then if the switch on this area, if the switch dies, or if this rack dies, all my brokers are gone. So you never want to have all your brokers in one rack. But it's the same thing with availability zones, like whether you have east, west, you want to spread your brokers across, and there's different ways people do this. But when you do this could be the cost. So you want to make sure that the brokers have the broker.rack property set, and you'll see that it's an all or none type thing, very important. Then Kafka will try to place those, place the partitions across the brokers, and we'll try not to put the same partitions on the same broker. So this is very important. And by default, the consumers are only able to fetch from the leader. But remember, in a newer release as of 2.4, we allowed the consumers to fetch from the followers. So the consumer can now fetch from the follower, and the consumer is happy, right? But you still have to have these broker rack properties set, right? And there's also the concept of having a set. If you look at this, right, there's also the client. So following fetching, the follower fetching was introduced in 2.4. You have the client rack property for consumers. Brokers must also have the rack awareness configured, and we mentioned before. And then you also have one more property, and this is all listed in your notes, but there's one more property called replica selector class. So the clients can be able to understand which of the followers, or just the replicas, are the closest to it, right? So this is something to just be aware of, very important, because if you can access the data closer to where you are, then your performance is going to be a little bit better, right? This is something people have wanted in Kafka for a long time. And then this other thing to understand here is producing duplicates to the log. In other words, remember, topics have partitions, partitions have log. The logs is where the messages or the events or records are stored. Now, this is not something that happens regularly, right? This is not something that is going to happen because you will not run with this. You will always have the right setting in your production environment to avoid this. But what this is showing you is that it's possible that if you don't have that idempotence set to true, where it's called enable idempotence, it's a property that you set that allows the producers to avoid duplicates, then duplicates is possible. And this is where this is trying to show you. So if I have a producer producing to Kafka, I can have multiple messages in flight. And let's say I have X equals all. That means I'm waiting for the leader and the follower to respond, right? So let's say in this case, message 1 and 2 goes to the leader. The follower has message 1 and 2. This follower has message 1. But then here, there's a failure. So if you look at this here, right? The leader fails before the record batch M2 is committed to all the brokers. So the leader fails before M2 is committed to all the brokers. Then the new leader already has the M2, but because of retries, right, the producer continued, it never got back the acknowledgement. So the producer retries and notice that the M2 is here written in the log again, right? So it's possible, but this is not something that will happen. Why? Because if you run with this property called enable.idempotence, you set this to true, then it avoids that duplicate. And you say, well, how does that happen in Kafka? It's a really simple thing that they do. So every producer is given a producer ID, called the PID for producer ID. And then you also tied your messages tied to what's called a sequence number, sort of like in TCP/IP, right? Remember when you do TCP, you do a TCP and you send a message sequence number and then your acknowledgement, it takes a sequence number and adds 1 to it. But this, I mean, I'm just saying that it's a very similar concept here. But what you're doing is you send a message, M1, and here's the producer says, hey, my producer ID is 1. That's a unique identifier. Then the sequence number is that the number that is given to this producer, it will be incremented with each message. So in this case, the producer 1, sequence number 0. Next message, producer is the same producer ID 1, doesn't change, sequence number 1, right? But let's just say I don't get back you don't get your acknowledgement for the message number 2. So retry, it retries to send a message, but then if the message is already in the log, it says, hey, wait a second, I've already seen, because the message with the sequence number 1 already exists. So it does not allow this to be saved, right? So the broker will recognize the sequence number from the producer and says, look, I don't need to add this to my log because I already have this. And this information, as you'll see in your notes, this producer ID and sequence number, right, will be occasionally snapshot into that the partition where your logs are in a hidden file. And the hidden file begins, any file in Linux that begins with a dot is a hidden file, right? And it's called .snapshot, which will have your producer ID and sequence number. So it helps to recover for the broker recovery. But the whole point is, this is just some background information for you. And the key point to let you know is this previous page will not happen. You will not have duplicates if you just set this property in your producer. Just one line, just make sure it's set to true. And that's it. So this is how Kafka avoids the duplicates. And there's more details you can look at, but we don't need more. And then how does Kafka avoid out of order messages? Same thing. We can have multiple messages in flight at the same time. And we know that the producer has retry. If I'm a producer, I want to send my data to the broker. And if I set with X, then I want to retry. If I don't get my acknowledgement, I'll retry. And I want to continue to retry until some point. So if I send message 1, and message one. So in this case, right, retry is greater than 0. You can have multiple messages in flight, but I have the message one that I send the batch and then that fails. But then message 2 batch comes in and message 2 succeeds. Then now message 2 is in and I'm still going to retry. And when I retry 1, then 1 comes after 2. And this is considered to be, this is now out of order, right? So this is not something that would happen in Kafka. Why? Because when you have the enable idempotent set to true, which you should always use, then remember the producer is given a producer ID and has a sequence number, right? So you send the message to producer ID 1, sequence number 1. So look, and then the next message, message 3, producer ID is 1, sequence number 2. But it says, wait a second, I cannot accept message 3 because it's out of sequence. So it needs to wait for message 2 because you see the producer with the producer ID 1 had the sequence number 0. So I need to see producer ID with 1, the PID of 1 needs to now have the sequence number of 1. That's the next higher sequence number. I'm not going to have the 2. Okay, so in this particular case, just know that it's possible to avoid it. So the broker will notice that the sequence number for message 3 is not the next one. So it sends the out of order sequence exception. And this is in your notes. I'll give you this also in the documentation, right? But the whole point is, this is just good conversation and for you to understand if you have to explain to someone, but you don't have to worry about it because all you have to do in your code to avoid out of order and to avoid duplicates is to set this one property right there. When you set this, remember idempotence means the same operation can occur many times without changing the outcome, right? Sort of like taking the absolute value of a number, right? Or x assigned 5, you can do x assigned 5 10,000 times. It will still be x assigned 5, doesn't change the result. So idempotent, same thing can happen many times. Like you can send many messages, but it won't not store the duplicate. Anyway, but I'm sure you have your own definition of that, but just know that you don't have to worry about it. Enable idempotent set to true, and you don't have to worry about that. But that's good discussion for you to understand if someone says, hey, Shilin, you're our Kafka expert right now. Can you tell me how does Kafka handle duplicates? And Shilin can go into details and explain it to them. And then Gang says, trade-off for enabling idempotent performance. No, actually, there's minimal lack on performance at all. It's more with EOS. EOS, when we start to look at transactions, you do get a little bit of overhead, but this for enable idempotence is insignificant. Yeah. Idempotent requires acts must be also producer delay may increase a little bit. Well, actually, remember, you don't are you sure that you have to have acts equals all, or you just have to have so if you require that, right? Because a leader acts, that's interesting. But so it's really insignificant from what I've seen. And in production, we always recommend the customer run with acts equals all and run with enable idempotent set to true and in sync replica set to 2. How to ensure order? Just set the property enable idempotence, right? And the broker will take care of all of that happens automatically. Once you run that, set that one line in your code, that's all you have to worry about, and the rest is taken care of. But it's really insignificant as far as performance is concerned, like any lag. And sometimes people will say, well, why isn't it the default in that case? And I haven't heard some really great explanation for it. And I think maybe this could be just because not everyone wants to run. Maybe Shilin is right about this one. I haven't even thought more about it. If you don't have to go with acts equals all the time, and maybe it's not by the default. But as far as performance wise, I wouldn't worry. There's not much at all. Nothing significant. Then problem reprocessing record, they say, is required. Now, they said there are infrequent situations where the consumer's application must begin processing at an offset other than the default, right? and the application was updated and records need to be reprocessed, they say that's a one situation. Or maybe the new release of the application had some errors, right? And they said the previous release of the application must be restored. So you have to replay the log or reprocess the records in the log. So there's some situations where you do have to reprocess. Now, when we look at this, we note that consumers will process the data and store their offsets in Kafka. And consumers store their offsets in the underscore consumer offsets topic, especially when you have like the auto commit set to true. But they say if a valid offset, right, exists in the offset topic, then the consumer will start from that offset. But what happens if the consumer doesn't have a valid offset? In that case, it will look at this property called auto offset reset. So remember, this property called auto offset reset, it determines how the consumer proceeds, but the property is only used if the consumer doesn't have a valid offset, in which case you can determine how you want your consumer to behave, right? So if the consumer group starts for the first time, right, doesn't have you say, well, I can start from the earliest. Or if the offset is less than the offset, the smallest offset, or if the consumer offset is greater than the offset, let's say +1, right? You could say, you could decide whether you want to do earliest, latest, or none. If it's the earliest, you reset to the earliest available offset. If it's the latest, you start from the end, right? Reset to the latest available offset. And if you say none, then it says throws an exception, as you can see in the page. But the whole point is, remember, the important thing to remember is the auto offset reset only applies to when it does not have a valid offset in the underscore consumer offset topic. And then Gang has a question, says, all topics offsets in the cluster goes to the single consumer offset group. Yeah, and then partitions. Wow, Shilin, you have a great memory. I've been teaching this class for a long time, and I still don't even care to memorize the number of partitions. I just say, so this is this is good. Yeah, so just note that the offsets are written to underscore consumer offsets topic, and it's spread out across the brokers. Yep, you don't have a problem. Okay, so now solution, reset the current offset. So let's look at what we can do here. In the API, in the Kafka Consumer API does give you a way to move around. Think about this, just like in programming, right? In the C programming or whatever, you can move through the file, use the file pointer to move to any position in the file, right? So you can move at any point in the file when you're programming, like using C. I can seek the position in the file, right? And I think all of you guys are familiar with that. Well, guess what? In Kafka, the API, we gave you different methods to allow you to move. Remember the log, think of that the log where all the events are coming, there's offsets, and the events are stored at those given offsets, but it's like, just like you see a whole huge data file, that's what it's in the log, right? But the whole point is you can move around. So we have different methods. If I want to get the offset of some record, I can say, yeah, position and give the partition, topic partition. And this one, I like a lot, the offsets for time right here, right? I can get the offset for giving partitions by timestamp. Okay, so I give the timestamp to search for, and then I can get the offsets for that particular partition, a timestamp, which is great. So I'm using a certain timestamp, I can go back to a particular offset in the log. So look up the offset for giving partition by the timestamp. Very, very powerful. So if an event happens, let's say there's some kind of failure at 12 p.m., I can use that timestamp and then given the offsets that I need to go back, and then maybe go back to like 11:59 and then start to consume the data from that point, something like that. But the whole point is very powerful. Then changing offsets, just like I mentioned, we can move to different positions. I can seek to a particular offset, right? So seek to the specific offset in that partition, or I can seek the beginning again, seek to the first offset of each. Again, if you've ever taken a C class or any other programming class, it's just like, here's the file. I can seek to move the file pointer to different points in the file. Well, yeah, in Kafka, you need an API to allow you to do that. So you can move around to different points, right? And this is very powerful. We gave you some other information about it. But one of the things you can do is when you use this offsets for time to be able to find the offset for giving time, there's also a command line option for your Kafka consumer groups that you can use to basically reset the offset to a certain date and time so that you can then point the consumer group to that point so that they can start consuming the data from that particular point. And we added that to your notes. But just note that it's very powerful and you a lot of features there with it. The API, there's a lot of things to the API, but it's great. And then this one says reset offset to a particular timestamp. We're just giving you an example of the code, right? So you add each partition to the timestamp and partition and timestamp, to the hash map. And then what do you do? Get the offset for each partition and then seek to the specified offset. And the question says, what is the use case for this? And this is the one I just sort of mentioned. Imagine if there's a failover like data center or whatever. The bottom line is you can use this offset for time and get the right time and then point your consumer to restart consuming the data from the right place. Very, very powerful, right? And so just a use case, a sample of using it there. And then reset the current offset. Remember, seek to the beginning of you can do this, but here's the thing. We saw a little bit about the consumer rebalance listener before, right? Remember the rebalance listener if I implement the rebalance listener, I have the methods that are part of this, on partition revoke and on partitions assign. I can decide what to do when I know my partitions are going away, right? So what do I want to do? Okay. Example, you can seek to the beginning of all partitions that have been read by the consumer for a particular topic. You can do, so a lot of different things you can do if you want to. But in this particular case, we show you subscribe to the topic and register the rebalance listener. Then you pull, get your metadata. But the whole point is when I know my partitions are going away, or in this case, when I'm being assigned to a partition, I'm being on partitions assigned. When I'm getting my partitions, then what do I want to do? Seek to the beginning. So again, very powerful implementation. If you implement it, you define the methods, you can do whatever you want to do. So the rebalance listener is a very important thing to be aware of. And then we come to this other process when you're writing your code. This was one of the questions someone asked me before. Say in a rebalance scenario, any records that were processed but not committed. Remember when I said rebalance occurs, it's like a fire drill, like you have to walk out of the building, right? So any records that you have that were processed, but remember, if you process, you subscribe, you pull, you get the record, you process the record, you have to commit the offsets, okay? If you did not commit it, then there's a problem. Then if a rebalance happens, then the next consumer will only go from where your last, if I only committed 5. And then she'll say, on partition assign can only be called for next generation owner client after on partition revoke or previous owner client finish. Is that a question or a statement? I'm sorry. You say when you do on, yeah. Okay, so in this case, when you do you have the consumer rebalance listener, and in this case, if I'm reading it correct, you say can only be called next generation owner client after, but yeah, so I think it's whenever the rebalance occurs for whatever reason that it's going to occur, whether that's a next, for whatever causes it, right? Then if I have the implementation of, if I have the definition of on partitions assigned, then that would take effect. So I'm not sure if I reading. Yeah. So I don't know if it only has to be the next what I think it's available for any time, because I know we saw this before. Anytime you have, anytime you implement the consumer rebalance listener, if you define those methods, then I think it's available for whether it is on assignment or on revoke. And
yeah, and the question is actually for example, partition 0 was owned by client 1. Then there's a fire drill, right? Everyone has to leave. Then the partition 0 might be assigned to another client of next generation or next assignment.
correct.
So I mean, this partition revoked will definitely be finished on the previous owner before the partition assigned is called our next owner, because otherwise there may be overlaps, right, in the times.
Actually, okay, I think I see what you're referring to. Actually, that's a good one. Let me actually think about that a little bit. Good question for that. Will it be? Let me put that here. Yeah. Okay. There we go. Yeah. Very good question. So yeah. In this particular case, from what they're trying to show, it's pretty simple, but it says, look, you have this, the consumer did not commit. So then when that happens, the new consumer here ends up reprocessing. So when consumer 2 starts, right, because there's a rebalance, the other consumer takes over. So then it continues to process this because it didn't know about this was never committed. So it reprocesses the data. And yes, when you do the on partition, because I don't think I have to do anything with the revoke, but as long as I implement it, I think it should take effect for at any point, but I will double check that. I don't know if it's only for the next, yeah, but I would double check on that one. And maybe since you're internal, Sean, maybe you might even find out before me. Okay, so let's go. Yeah. So with this one, so consumer reprocessing after failure, this is a possibility. So this is something that you need to keep in mind. So then they say, well, in this case, how do we fix this? And we also added the notes for this. But the important thing is we can store the offsets with the data in whatever destination system we're writing the data to. That's one way that we can do that. Or you can do like what they say when they talk about leverage idempotent writes. That means you can say I'm writing many times, but it's not going to change anything to the sync system. Again, I think we have some good examples of this in some of our GitHub code and other places. But for now, just know that this is a possible scenario that can happen. And let's say handle the data offset atomically. So how can we do this? In this case, it's just a general idea that they're talking is this is just pseudocode. They say, look, I seek to partition while true, I pull, and then I get my data, begin transaction, then insert the data into database, insert, and then commit my transaction. In other words, they're trying to say that you're doing it atomically. You're doing everything as part of a single transaction here. So you handle the data and offsets atomically, right? Then in that case, right, rebalancing isn't going to end up reprocessing the data. We are going to talk about exactly one semantics, which will avoid, well, not everything, but it will help you in some other situations as far as doing transactions. But you still need to know how to handle these kind of situations. And then this one says use an idempotent sync. That's a second example right there. So the sync supports, I pull, I get my data, and then maybe I'm inserting to a database, and then I say commit async. And they give an example of this. So the system needs to support the idempotent writes, and then the consumer offsets, they say will commit the commit occurs after processing, which gives at least one semantics. Again, this is not going to solve your problem right now. And sometimes our course developers put certain things together that is not as coherent, but just know that the general idea is that there's ways to handle those things if they happen and you want to be aware of them. And like I said, afterwards, I would take you guys for a tour of where I get my information from, and you'll see that lots of details where I will show you. Problem with large messages also, the broker default, the large message in Kafka is 1 MB, but we want to avoid going much larger than this, right? The producer default is usually 1 MB. And in Kafka, your message may be just 200 bytes, or it may maybe like 1K or 10K. But think about it. If 1K is about a page of data, right, roughly a page, 10K is like 10 pages of data, roughly. I mean, I'm just estimating to make it close. There's a lot of, so when you get to 1 MB worth of data, that's a lot. But then if you say, well, if I'm using images, then of course that's a different situation. If you're using images and stuff like that, or some binary large objects, then you have to be aware that yes, you could have large images, and there's different ways to handle large images. We will see that coming up in just a second. So if you do decide to limit the message sizes, know that you can have some issues like poor garbage collection performance, less memory will be available for other important tasks that the broker needs to do, and then more resources need to handle requests because your message size is all right. So increasing the message size, you need to be careful with that. But if you have to have bigger messages, what can you do? And remember, we talked a little bit about compression. Compression, you can compress. So compress the message. Of course, compression is always a good thing, right? Producer batches and then compress the record batch, as I said. Then a compressed batch is stored in the brokers. Stored on the brokers. And then the consumers will decompress the message. And remember, compression is a trade-off, time and space when it comes to algorithm. And when I say compression, it's just a single, you just specify the compression type in your producer. Say compression.type. Is it going to be gzip or snappy or whatever you decide to use? So it's pretty straightforward. But that's one way to do it. The second thing is to pass a reference to an external store. So let's say you're storing it somewhere like in S3, and you just pass the reference to it. So you store the data, get the reference, almost like what we saw with our schema registry, right? Store the data, get a reference, and then basically write the data to the data store and receive that reference. And then when you produce the reference record to Kafka, they say, we'll delete the prepared reference record due to compaction. It goes on step by step. But the whole point is, when you store the data into Kafka, the consumer can use that reference to be able to get your data and you can process it. So this is just something, consumer will read the reference and retrieve the data from whatever external system you're using. And this is just something, some people call this the clean check. Very similar to schema registry type of setup. And then the last one is to do record chunking. This one is not as easy, but again, it's something, if you come from like the big data world, then this is more, you're probably more familiar with this, but you have a large data set and you can find a way to literally split it up. So you implement what they call it's just a class that is going to break it up. We call this here a message chunker. You could call it whatever you want, right? Breaks up the large payload. Then make sure you have the enable idempotent set to true, and then go through this process. Gang says, on the few slides on duplicates, is the below a fair statement? It seems that Kafka as a system cannot guarantee exact ones. No, Kafka can guarantee exactly ones, and we will actually talk about it coming up in just a second. So we do have exactly one semantics within Kafka, and and this is it's a really amazing thing that was added, because a long time ago there was a famous blogger who said, hey, it's impossible to achieve exactly ones in distributed systems. But there are two researchers out there called Cheney and Lamport. Cheney and Lamport. They came up with this paper that showed how you could achieve exactly one semantics in a distributed system. And then when this paper came out, what Confluent did as a company is they took those concepts and then implemented it in Kafka. And so now we call the EOS, exactly one semantics. And we'll see where you can process the data, you consume the data, process, and produce the data. All happens atomically as part of a single transaction. But it's only within Kafka that it guarantees the exactly ones. Yeah, so we should see that coming up again. We'll see that coming up pretty soon. But this is just saying, look, if we have large messages, we really want to try to do these kinds of things, and you guys can read about it. So overall, we're not showing you how to do it yet, but we just say, look, try to break up the message, use this clean check or compress. There's different ways to look at how to do it, right? And then now, the previous question was a perfect segue into exactly one semantics. Like, what is exactly one semantics? And I'll just do a quick recap. So remember, there's two researchers that actually came up with this concept of how do we do exactly one semantics in a distributed system. And Confluent took that concept and used it to come up with EOS. So what they call exactly one semantics. And it's, from a developer perspective, is very easy to use. We'll see. It's just like you just set a couple of properties and if you're using low-level producer code or the Kafka producer, there's a few things that added to the API. And if you're using Kafka streams, it's even easier to use. And most people use Kafka streams when they're doing EOS. So it's very easy to use. So let's look at that now. One, transactions with exactly one semantics. How it works. Number one, you will have the idempotent producers. So you will have to have this property, enable idempotent set to true, right? That has to be set to be able to do exactly one semantics, and that's set in the producer. That will make sure that Kafka partitions are free of duplicate records. Then there's another thing that we'll talk about too. Let's read. Schilling made a comment in Kafka. Say, if it is within Kafka only, yes. So exactly one's guarantees is within, when you're using EOS in Kafka, it is within Kafka. It doesn't guarantee between Kafka and an external system. There's no way to guarantee. Yeah, ultimately write to external, commit to Kafka are separate steps. They can fill example, blah, 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 or you can commit Kafka also internally if you consume Kafka. Yeah, so if you want exactly one semantics between Kafka and an external system, you have to manage that yourself. But within Kafka, exactly one semantics is guaranteed to work when you have these things that we're going to talk about. The guarantee is within Kafka. So if let's say you write a Kafka Streams application and you're consuming the data, processing the data. So you could do basically like banking transaction in Kafka Stream. As a matter of fact, 14 months ago or so, right before we went into lockdown for COVID, I was in Sao Paulo, Brazil at one of our customer sites. So I did an on-site class for them. And they are they're much like PayPal. They do a lot of transactions online. And one of the things they were really happy about is that they started to use Kafka a lot for a lot of the payments. And the guy said because I always asked, how's everything working? And they were really, really happy with it. So exactly one semantics does work. There's a few things you have to be aware of, but it works really well in Kafka. So now, but just like in the database world, if you ask most people who work with the database, say, hey, tell me how transactions work in a database. Not many people can actually tell you how transactions work in a database, but they know that they can do transactions with Oracle, right? They can write applications and they know that, hey, I can do the transactions here, but they may not know the details of how the bin logs and how everything else worked in Oracle. So in Kafka, you'll see it's pretty much the same thing. It's very easy to use as a developer. You just set a certain properties and maybe use a little bit of the new API, and you're pretty much guaranteed that it will work. So in this case, what do we set? If we're using a Kafka producer at a very low level, we want to set the idempotent set to true. Then we want to set a unique ID called the transactional ID. This is just a string, just like you set with other properties, like you set a group ID, but this is called a transactional ID. So it will be one line in your producer code. So now I have idempotent set to set to true. I have transactional ID, and I just set that, right? And then that's on the producer side, right? And of course, you will want to run ax equals all as well in this particular case. So I have ax equals all, I have idempotent set to true, I have my transactional ID, and I'm writing my Kafka using my Kafka producer. That's literally that, I'm guaranteed from the producer perspective. And then on the consumer side, I have to set the property just called isolation.level and set the read committed. Then you say, wow, when I say read committed, what does this mean? Well, that means you will read the committed messages only. You will not read the aborted messages. You will filter those out. You will only read the committed messages as the consumer. You will filter out the aborted messages. Also, what does it mean? It does not mean that you will not be able to read other messages that are not part of the transaction. You can read the non-transactional messages, and you can also read the committed messages, but you will not read the aborted messages, right? And so, and for other clients, other than the Java Scala client, because you can use librd Kafka, right? It now has exactly one semantics. For some time, people, if you are using other clients and you couldn't do exactly one semantics, in other words, you couldn't do transactions in Kafka because this library didn't support it, but now it's complete. So you can have a transaction-aware consumer and full producer transaction support as of certain versions. So let's talk a little bit more about exactly one semantics. Okay, now this is, just to let you know that there's close to a 90-page document, or less than 70 pages or so, just on the KIP, and then there's a design document that's probably close to 90 pages or so. All of this, and what we've attempted to do here is to just walk you through the basic steps of transaction. Don't feel like you have to memorize this or anything. All you need to know is from a developer perspective, if I'm writing code and I want to do transaction processing, in my producer, I set the idempotent set to true, and I create a transactional ID and run with ax equals all. And then I probably just have to use a few additional methods that have been added to the API, and I'm good to go. If I'm using Kafka Streams application, I only need one line that says processing guarantee and then set to exactly one. And when I do that, it automatically enables the idempotence and set it to true, right? And it's really, really awesome to make that happen. So Kafka Streams makes it even easier for you. But let's do a walkthrough of this real quick. And then after we do a walkthrough of this, it'll probably be right about, there'll be a good time for a short bio break. But let's just do a walkthrough of this one. So assuming that this is a Kafka Streams application, notice how it has a consumer here and a producer, right? So this is like your Kafka Streams application. I'll draw this. And this is called the Fund Transfer app. It wants to be able to transfer some money, right, from one account to another, right? And that's what this is all about, this picture here. So we want to walk through this in just a second. Okay. And actually, I'm sorry. Do you guys mind if maybe we take just 5 minutes right now? I'm sorry. I just want to grab some water real quick, and then we'll come back. So just a quick 5-minute bio. Martin said, yay. Okay, I need coffee. Okay, awesome. So I just want to grab some water real quick. Let's just make a quick 5-minute bio. Sometimes, okay, quick 5-minute bio, and then we'll come right back. So that makes it at 10, let's say, what time is that going to be? So at 2:10. I'll make it 211 now. Okay, be right back. So question, is it common use case to pass large files like document through Kafka? You can have large files and you could process the files like regardless of how large it is. And I'll tell you why, because when you're processing that file, you're reading individual like records out of that file, right? So to speak, like the data, the bytes that you're sending from it. And you're then doing whatever you need to do, depending on what you're using. Like there's even a file source connector, but if you're processing the data and sending individual records, you could go gigabytes, terabytes, whatever size. But if it's a blob or something else like an image, then you want to be careful because then you have to figure out a way to store that, like we saw before, using that clean check, stored somewhere, and then pass a reference so you can access it, or a way to break it up and do those different things. Brett says I'm on the jump. Brett is on the ground floor, so he will not be jumping. It's funny.
Hi, Hussein.
Yes, yes.
Yeah, I'll just ask the question. Yeah, so example, if we are intending to like pass like files like PDF or image, right? It is usually rare that we do that using Kafka, right? Because that would require the multi-part solution that you mentioned earlier on breaking up the messages, right?
Yeah, if it's in other words, if it's a blob like a binary large object of some sort, but if it's data, you will, in other words, you can process like if the file itself, right, those individual records of the file will be written into Kafka, but each record probably is not going to be too large if you look at it. So let's say you have a file, the file could be a terabyte in size, but each record in there is not a continuous, it's maybe, who knows, maybe, or each line. So I guess it's how you are thinking about it, maybe.
So the solution, the scenario I'm trying to paint in this case is like maybe we are looking at like PDF files or images, like literally.
Yeah. Okay. Then that those kind you definitely have to go through like what we saw, like find a different way to do it, because it's better not to use them because Kafka prefers it less than 1 megabyte. Of course, if you're running in Confluent Cloud, we've optimized the environment so well that you can use like 2 to, I think they have up to 8 megabytes now. So regardless of what that size is, they'll be able to work with it. But by default, yes, you want to keep it less than 1 megabyte. And if it's bigger, then you have to find one of those other methods to break it up.
Okay, understand. Thank you.
Absolutely. Okay, let's get started with this one. Welcome back. Thank you, Martin. Martin says, yeah, at the end of the course, thanks for bringing that up. One of the things we do, I mean, as an instructor, we're not at the end yet, but one of the things I tell people is like, I teach because I really enjoy it, but over my career, I've done a lot of different roles, like hands-on, in production, in infrastructure, different places. I've had a lot of different hats over the years, but I enjoy teaching because it's a lot of work, but it's actually fun. You force yourself to learn new things. So at the end of the course, you guys would get to give some feedback, and I'll give you guys a key that you'll use for the survey. So before you leave at the end of the day, please, it would be great if you guys could take like 5 minutes of your time to do that, because it's really important. This way they know that Hussein has been working and not just on the beach, because I do want to go to the beach, but maybe next time I can. That's a thought. Who would know if I'm sitting on the beach and as long as it's quiet and I have a really portable modem, and I'm doing my lecture. Ooh, that's a good thing. I have to think about that a little bit more. But yes, but at the end of the course, you guys will have a chance to get feedback, and please let us know. And I think it's a lot of information to absorb, but when we wrap this up, I will show you all the critical places you need to go to be that expert. And then it's all going to depend on you, like how you feel about the material. I mean, how you absorb the material, not feel, but how you can absorb it. Okay, so let's come back to this one now. In this particular case, it's a transactions. We started by saying that this is a Kafka Streams application, and it has a consumer and a producer. And we have this transfers topic, right? We want to be able to transfer money from one account to another, right? So this is what this is all about. Imagine you have this, so it's a Kafka Streams application. Now, if you look at the picture carefully, remember Kafka Streams application has a consumer. And if you have a consumer, that means there has to be some consumer group coordinator, right? And the group coordinator is one of the brokers in the cluster that functions because the broker is multi-threaded, right? Broker software is multi-threaded. So one of the brokers in the cluster has to function as a group coordinator. And that broker is there because consumers need that. Then now also, because you are using the transactions API, Kafka also says one of the brokers need to function as what's called the transaction coordinator, right? Because now you're using the transaction API. That's the first two things that we need to be comfortable with. And then Kafka then says, well, with this transaction API, notice there's an additional topic. Notice this topic with the underscore that always tells you it's a special topic in Kafka, like internal topic. So the topic is called transaction state topic to store the transactions. Sort of like, think of Oracle with Oracle bin logs, the binary that keeps track of every event that is going on, right? So this transaction state topic is here to keep track of all the events going on with the transactions. And we note that consumers heartbeat to the group coordinator. The group coordinator manages writing the offsets, right, to the special topic in Kafka, the consumer offsets topic. And this is just to begin with. And this application now will need to transfer some money from one account to another, right? So it's a real transaction, like the real financial transaction. And just this is how the whole thing starts up. So with this big picture in mind, yes, the transfers topic, a certain number, and here's the balance topic, okay? And this is now, let's go to the next page where we will get into more detail. So this sets the stage for what we want to do. So the first thing someone might ask is, well, how does the system know? And I don't think you guys asked me this question before for the first, but sometimes in the course, people will say, how do we know which broker is going to function as the group coordinator? Because we know that one of the brokers have to function as a group coordinator, the GC, right? So Kafka would do a hash of the group ID modulo n. And you say, well, what is n? That's the number of partitions in the consumer offset topic right there, right? So in this case, this is it. So we have your Kafka will do this and then figure out, okay, one of these brokers, and in this case, let's say this one becomes the group coordinator. So that's how it figures out the group coordinator, right? Now, in this case, the next stage, we'll say, well, how do we figure out the transaction coordinator, which is the same thing? Because remember, the producers now will have just a string that's a transactional ID, just a transactional ID. And that's just a string that you set, whatever you want. But one of the brokers in the cluster needs to function as a transaction coordinator, right? And any one of the brokers could be the transaction coordinator. But what it does is it does a hash of the transactional ID modulo M. And you say, well, what is M in this case? Is the number of partitions that is in this topic right here, in this transaction state topic. And then it figures out, let's say it says, okay, this broker here, broker 2. So let's say broker 1 in this case is the group coordinator. Broker 2 is the transaction coordinator. I'll put your TC transaction coordinator. Okay, so this sets the stage for this. And the next thing now, let's go along. We have a transaction coordinator, group coordinator. In this case, in the producer API, we note that the producers, remember producers always have a producer ID, right? but then now we have a transactional ID. So when the producer connects to the transaction coordinator, right? This is a very important part, right? The transaction coordinator will record to say, hey, look, you have this transactional ID, and here's your producer ID. Then it says, okay, I now see you're registering, and I'm going to tie your transaction ID here, your transactional ID to your producer ID, and I'll write it into this transaction state topic. I write it into the log. And then I also increase this number. They call it the epoch. It's just like a piece of metadata. Think of it as just a number that I can associate with this particular transactional ID. So the epoch is with the transactional ID. I'll say TID, and the TID is associated with the producer ID, right? So all of this is now tied together. This epoch is just some number, right? And so in the API for the producer, it just has another method to init transactions. And I'll show you guys a sample code for this when we get to it, right? So the producer begins the transaction. It says, okay, and it's recorded in the log. So every single step. And this epoch now is very important because when you're doing transactions in Kafka, you want to avoid zombies, right? And so what's a zombie? Imagine the producer, like the situation where, let's think about it this way, like in a movie, if I have zombies running up to your house, but if you have a very high fence, the zombies can, it's difficult to come over. So to avoid zombies, you fence them off. Now, if you say, how do you fence them off, right? So this epoch that is given, that's a unique number, right? You could think of it as metadata or whatever you want to call it for every transactional ID. So they say once the epoch is increased, like let's say this epoch is set to 2, for example, then any producer that comes in with the same transactional ID, right, and an older number. So let's say someone come in with a transaction ID and have an epoch of 1. That's like the previous producer is going to say, sorry, you're not allowed. You get fenced off because you're old. You have a lower epoch, right? And so in that particular case, you have an older epoch and you're considered to be a zombie, like a producer that's died and trying to come back to life and produce data as part of this transaction. You say, no, I'm going to fence it off from all future transaction rights, right? So if those producers try to produce, they will be rejected. So the whole point here, just to know, is that one, when you're doing exactly one semantics, because you create a transactional ID, your transactional ID will be tied to your producer ID, and you have this unique metadata called the epoch. And if for whatever reason the producer is producing, they always have the current epoch, like they'll always be increased. And so if an older producer comes back and have the previous number of 1, and it says, hey, I have the same producer ID with this transactional ID, but my epoch is, I'll say, sorry, you're dead. You cannot come back, try to produce to this topic. So one thing, and you can look at more detail in the documentation, but for now, just know that if someone asks you, how does Kafka handle this, zombies, it's because of the epoch and the transactional ID, right? And so this is good. And it does something. What does it do? They say it enables reliability semantics that can span multiple producer sessions, since it allows the client to guarantee that transactions using the same transactional ID have been completed prior to starting the new transactions. And that's a note we added into your documentation. But a lot of stuff that just know for now, hey, when I use this API, all of that is going to be handled. And then here's the transfer now. I say, I want to transfer $10 from Alice to Bob. This is what the application wants to do, right? That's what we're going to do. So my consumer is going to be consuming, I subscribe, I pull, that's my Kafka Streams application. But the goal now is to transfer from Alice to Bob. So then I go to the next step. I begin transaction, another method in the producer API. I begin transaction. And when I go to begin the transaction, how does the epoch get mismatched? question that came in. So in that particular case, what they're saying is it's not so much a mismatch, but let's just say that, yeah, not the same producer, but let's just say, and because when you're writing the data, right, you have an epoch associated with your current transactional ID. And if you are the same producer and you have that same transactional ID, then you should have the latest epoch. Let's say I have the number 3. I'm the current producer. If something happens, right, and let's say the old producer starts to come back and try to produce the data, but it has a lower epoch, it's rejected. So in other words, it will always be, the epoch will always be incremented as you go to produce from the producer. And that's better, there's also more detail in that discussion, but just know that the transaction coordinator always increments that epoch, right? That's associated with the transactional ID for a given producer. And so let's say if Martin has the ID of 1005, no, not so much a rebalance, because actually rebalance would be from the consumer side, but let's say from the producer side, maybe some failure somehow. That's a good question. Like some failure maybe just something that stops it. You stop it somehow, and then you just maybe. Actually, that's a good question. Like, I had some great examples for that, and now I can't recall it. But anything that will stop this producer from, well, you see, the intermittent network won't necessarily do it, because you will still have a certain number of retries from the producer perspective, and then your retries will eventually end up in the destination. Let me think about that one a little bit, actually.
I can give some my understanding, because
please, go ahead.
I read some instruction before, because the transaction ID is not, this is transactional ID, not transaction ID. So this is a fixed,
yes.
This is a fixed across multiple restarts, right? And remember, the producer ID could also be a fixed value if you have a producer ID. That means this mapping may have multiple generations. When you restart it, the TID to PID mapping could be the same, but when you restart it, then epoch, when you start new transaction, epoch number will be bumped. So the previous one, if it's a zombie process somewhere, it will be fenced off, right? If you have started a new instance of the same program, but they tend to have the same mapping, but then they have different epoch, and the first one will be fenced off. They cannot commit the transaction will be automatically aborted upon expiry of the transaction also. I guess that's the...
Well, your transactional ID is the string that you set, and the producer ID is one that would be given to you automatically. And the epoch, that epoch is the one, like as you just mentioned, that's the one that would be bumped, right? And so if you restart it, that's the part that I wasn't sure about. Like if you just say, if I just restart it, will it change this, right? But that's a good one, Shilin. Mm-hmm. But does it make sense? You guys, everybody follow that?
Well, I'm not too concerned about. I'm actually not that concerned about how the epoch got mismatch. I just need to know when it happened. I just want to know the whole scenario. So the reason is that the epoch will just keep running, right? Because you did mention that. I think that's one of the keywords. They will just keep increasing. So suddenly, an old one with the same TID and the PID comes back, but the epoch number is different. So this whole, I would say, key value pair of TID and PID, they will be rejected as a whole.
So if it comes back and it has a lower epoch, yes, it's rejected. Okay. If the epoch is lower, then it's rejected, because it says, hey, look, you have this producer ID and you have this string or whatever you set for your transactional ID, and you have this epoch you're producing right now, and you cannot be the same one with the older. You cannot be the same one with the older epoch, because you're now with this current epoch. So they reject the old one. And like Shilin said, if maybe because if you restarted it or whatever caused that to happen, which is what I was thinking about. Like, what could have caused it? But if it came back, but it had a lower epoch, then no, it's not going to be. It's going to be fenced off. Mm-hmm.
Okay, so we are only rejecting that current producer that is tied to the TID, right? So one TID can only tie to one TID.
Yes, for a given transactional ID is tied to the producer ID because every producer has a unique producer ID. Mm-hmm.
Right. So for some whatever reason, the old one, like the zombie, comes back alive. So there's another black box here is happening that some reason the zombie that comes back gets the same TID and PID.
Correct.
Okay.
Because
actually TID is the same across multiple restart because it's a fixed configuration value.
Your PID is when you connect, you get a producer ID, right?
Okay.
But your transactional ID is something you set. It's a string, transactional, not transaction.
Yeah,
and
it's the same. If you configure in the file, then it's the same across multiple restarts.
Correct.
The better way to say is it when one producer dies, so that TID will be assigned to another producer?
You know what? Let's do it this way. I'm going to take you guys for a tour at the end, and one of the things I'll do is I'll pull up this EOS, like what's called the KIP, Kafka Improvement Proposal, and then we'll see. Like I'll show you the detail in that. Do you mind? Is that okay?
Sure. Yeah. Like anything that can help visualize will be good.
Yes, absolutely. And so we'll do that. I will take you guys and you'll definitely. So this is good discussion, and like I said, most people to use it is very simple. But this makes you like that person that you can explain to other people and talk about it. But to use it, it's going to be very simple. Once you use the API or you set the properties, you're good to go, and it just works in Kafka. But so now we begin transaction, and we want to begin the transaction. So we'll come to this part to say now we're going to begin the transaction to transfer them from Alice to Bob. And here we say we want to start. So in this case, the part of the API is going to say, look, we want to be able to add these partitions to the transaction. So in this case, notice that the M0, the message is now written to P0, partition 0. And so partition 0 is now added to the transaction. Again, just a high level detail to say, look, now we're adding this as part of the transaction. And then if we go further, you'll see now, again, when you're sending more messages to the topic, I'm then adding now M1 to new message. The transactional ID is tied. Now I'm writing to P1 to partition 1. So in other words, it gets added as part of the transaction, right? So the message is saying, hey, look, I want to subtract or debit $10 from Alice, right? And this is important. So now let's just go to the next one. And then part of the API again, send offsets to a transaction, right? So very important part to say, what do I need to do here? I want to send the consumer offset and the consumer group information to the transaction coordinator. We'll see that it's very important. So it's actually this part here, send offsets to transaction requests. It's very important. So you want to be able to do this because we want to be able to commit. It's like a two-phase process where we will also process the data and commit the writing of the data, committing of the offsets, all happens as part of a single transaction, right? And if this transaction is to fail for whatever reason, right, we'll see how that works. But this is just another part of the API. Then we go to this next one, this transaction offset. It says, hey, what do I want to do? As part of this, the producer send the transaction, what they call the transaction offset commit request to the consumer coordinator to say, look, here are the offsets. I want to make sure that we can put this into the consumer offset topic. Again, we want the committing of the offsets, the writing of the data, processing, everything to happen as part of a single transaction. It's going to be all or none, right? So we want guarantees to say this is going to happen. We cannot have an abort. So you can have an abort or commit, but it has to be all a part of a single transaction. And then this one here, At some point, let's say if you say, okay, I'm ready to commit the transaction, notice that the transaction coordinator keeps track of everything. Says, look, I'm preparing to commit, right? I mark the transaction, say preparing, because I want to, at some point, I will have to commit or abort. And then you will see that special messages that Kafka will write to the log. And we'll go to this one here, this picture. So in this particular case, it writes these commit markers here to the log. These commit markers, which are special, they signify sort of like the end point to say, look, these are not messages for the consumers to consume. They're considered to be, some people say control messages, that's what they call it. Some people say commit markers, that's what they call it. But these are just special messages. They just say, look, this is the kind of like the result of this transaction, right? I want to commit it or I want to abort it. And they're not something that the consumer will consume, but it will signify at that point where you are commit or abort, right? And it's an all or none kind of thing. And then this one, oops, sorry, just a second. Make sure we do this real quick. Okay, so in this case, now, we're okay, yeah. So the transaction coordinator then marks the transaction as committed. In this case, notice this case, we're showing that the messages are going to be committed. And then finally, at that point, if it's successfully committed, right? Then the final step is sends the acknowledgement to the producer to say, hey, this is completely done. But it's notice the committing of the offset and the writing and the track of all the logs. I mean, everything that was doing in this transactional state topic. And all of this process happens, it's for all or none. There's no chance that you process the data and fail to commit, right? There's no chance that it will happen. It has to happen in this all or none situation. This is a high level overview of like how transactions work. I mean, how transactions work when you're using EOS. And again, this is just one person's view or one or two course developers' view of this whole thing. But what I'll do is I would take you to the documentation. We'll see the 70-page documentation towards the end. And I'm so glad that we have time to do that. So we'll have time to do that in the end, and I'll take you to it so you can see that. Okay. But transactions in Kafka, to use transactions in Kafka is pretty simple. This page just shows you that, hey, it's a sample of the code showing you just like how I init transactions to begin. I will pull, get my offset to do whatever I need to do, begin transaction, and then at some point, send offsets to transaction, and at some point commit the transaction. It's just showing you some of the API methods that you will be using, but it's we'll show you a simple example after this when I take you to the code. And then last part to this, right? You could do, again, if the producer does get a producer fence exception, then it closes itself. We know that. If the producer, and actually as a refresher memory, let's say if the producer for whatever reason failed, or if a new producer restarted the transaction and the old producer tried to start again. And that's what I couldn't remember. I knew it's a simple thing, but what Shailen was saying, pretty much, if a producer failed or let's say a new producer start and try to restart, right? So the old producer tried to start again, then again, so that's a perfect example right there. And like I said, I hate memorization, but this is in your notes. You guys will see this right here. Let me copy this right here for you. Actually, I just pull out because I was scanning. So here's a situation, for example, where you will see that. And like I said, I'm sorry. One of my things is I really hate memorization, but there's some good details you'll see everywhere. And so this is an example, right? The new producer would increment the epoch, so the old producer would be fence off. And that's in your notes. I actually was trying to scan to see if you guys had such a thing. I knew I've seen it somewhere before, just could not remember it. So then we come to the consumer perspective. Let's say from the consumer. On the consumer end, it's very simple to set the consumer up to get the data. All you have to do on the consumer side is set the isolation level to read committed. It says read only committed messages. It will not read the aborted messages, right? And then they say the broker provides a abort index so consumers can filter out the aborted messages. Consumers will filter out the aborted messages. And then this is a read committed does not protect against reprocessing after rebalance. So that reprocessing part is still an issue, but you can do exactly one semantics where you can write the message, the reading, the processing, the writing of the message, everything can happen as part of one atomically, in other words, part of a single transaction. So how can you fix these issues? Let's say for exactly one's message handling downstream, right? Let's say you can use this idempotent writes in an external system, like for example, writing to Hadoop or JDBC sync connector or S3, or you can store your offset and message together atomically in an external system. Like in a database, you could do that. You could even do it in like MySQL. There's some good examples on the internet where people are doing this by storing everything together in MySQL or something like that. So from a consumer perspective, it's very easy to make that happen. Then we get to now the situations where deciding number of partitions. How do I decide how many partitions I want? Because we know that in Kafka, partition is for scalability. See, Pia, partition is for scalability. That's how we scale. We know that if we have more partitions, then we can have more consumers processing the data in parallel, right? So here's the thing now. You go back to work and say, hey, gang, we need to produce a new topic called payments topic. How many partitions should we create in this topic? And that's funny. And gang says 3. and gang, this is where gang will say, well, let me think about it, right? And then you have to now come back to the drawing board. And this is where we're about to show you this concept. You want to look into it to say, hey, what is my target throughput, right? That's the T, target throughput for my producer, right? In other words, P is the producer throughput per partition. So the target throughput divided by my producer throughput per partition. And then what is the target throughput that I'm looking for? Am I looking for 60 megabytes per second or 80, or what is it that I'm looking for? You can increase the number of partitions, but you want to be very careful. Trillion is correct about that. You can increase it, you cannot decrease it, but you want to be very careful because if I have 3 partitions and I decide to increase to 30, so let's say gang decides to tell everyone in the company, we're going to use 3. And then 1 week later, he says, oh, wait a second. But everyone starts to use 3. They say, well, gang, the Kafka close or consumers are really slow. And then gang remembers and says, oh no, let's follow this. We'll try to measure the throughput we want divided for producer, and then we'll come with a maximum number. And then we have to be able to test this out in our cluster. And maybe you come up with the number 30, right? And then you say, well, you can always come and run a command to increase the number of partitions. In Kafka, really easy to do. You could do that from the command line. But the problem is when you increase the number of partitions, you then change the formula. So messages that were going to partition 0 before may now be going to partition 7, right? So you have to be careful with this. But what you really want to do is understand your workload before, and you want to play around with this thing to come up with some number. And if you have no idea, by the way, or professional, you'll see that about 32 partitions has been found to handle greater than 90% of all use cases. But I still want to be able to test it out to say, look, if I don't need 32 partitions, I really don't want to go with 32 partitions. And I want to figure out, maybe I need only 10 partitions. So I want to do something like this. And even if you forget about the scientific basis for doing this, you could even just play around in the lab. Like I could create a topic, let's call my payment topics, Payment, and I can go ahead and create one payment one, and then have this with 5 partitions, then create a payment 2 topic, make it 10 partitions. And all I gotta do is hit the up arrow key in Bash and change the name, just change the number, payment 3, that's another topic, and just change the partitions, for the number of partitions to make this will be like 20 partitions or 15, 20, and then do another one. This could be 30 partitions, do another one. This could be 40 partitions, do another one, 50 partitions. And the reason I'm saying this is I just want to show you that even if you do not have a scientific approach, it's very easy to run the Kafka topics command and say -- create -- topic called payment 1 -- partitions, 5, and then replication factor, and then just use the up arrow. And you could be in 10 minutes, you can have like 10 different partitions from 5 to maybe 100. And then you can just use the tools that we have. We have like a Kafka producer performance tool and Kafka consumer performance tool. You can use these tools to produce data to the topic and measure the throughput. What does it look like when I'm writing to the payment 1 with 5 partitions? What does it look like when I'm writing to 10 partitions? And you can measure the performance. So my whole point to this is this. Even without a scientific basis, you can easily sit in your lab and use your up arrow key in Bash to just recall the previous command, change the name of the topic and change the number of partitions, and create like 10 to 20 topics in just a few minutes, and then test with the performance tool we have, or use a sample of your data. Have the application write to a sample of your data if you're in your development cluster. So within 1 to 2 hours, you could have a great idea of what number performs the best. So if I see that, hey, at 20, I get like 60 Mbps per second. And then when I get to 30, I only get the same 60. When I get to 50, I get maybe 61. I see, look, I don't see much changes between them. Maybe I'll just go here and keep it here at 25, right? So in other words, it's very easy to try to figure this out, but I highly recommend that you do some testing. I was at a customer site once and they told me, hey, you're saying we have 999 partitions in this topic. And so I said, wow, how'd you guys come up with 999? And he said, well, because in Kafka, like they say, it's partitioning. The more partitions we have, it's the more scalable we can. But then there's a drawback also, because remember, every partition needs a leader, right? Every partition must have a leader. In other words, there's a broker that must be the leader. So that means if a broker fails, I have 999 partitions. That means there has to be elections. The controller has to elect new leaders for maybe 300, maybe there's 300 partitions on that broker, right? That 300 leaders that I have to go ahead and elect new leadership across the cluster. And that takes some resources to do that. I mean, it happens pretty fast in Kafka, but just know that increasing the number of partitions is not always without cost. And even if you use our Confluent Cloud, we actually, I think, charge customers per partitions. I'm not saying this is a good or bad thing, but you do want to do some testing to figure out exactly what your partition, what's the best for you, right? So you want to try some things when you're testing this out. Vary the producer properties, replication factor, message size, check the number, play around with the batch size, because you want to see how the throughput will be affected. If I have 5 partitions, so you play around, change the batch size from 16 to 32 or whatever, change the linger millisecond to see what kind. So you could do this consistently across all the different topics. And then from the consumer, when you want to see how fast the consumer is consuming the data, right? Play with the fetch min bytes. Remember, you say the minimum amount of bytes the brokers will send to you. And then this one say fetch max wait milliseconds, how long the broker should wait before sending it to you. So this is, again, some very important things to look at. And you can always increase the number of partitions, but be careful because it affects where the messages go. So it's a deciding the number of consumers. How does topic partition count affect consumer scalability? These are questions, but remember, the more partitions I have, if I have a topic with, so this is like 10, let's say 10 partitions, then I can have a consumer group. I can scale the consumer, right, with a lot of consumers to where each one can process the data. So in parallel, and we can do it pretty fast. So we give you the questions to these, or the answers to these questions. So I'm going to go on. So what are the consequences and options around increasing the topic number of partitions? This is just important to understand that if I have 3 partitions and I go to maybe 3 and I go to 10, then the formula changes because before I did hash of the key modulo number of partitions, 3. But now when I increase the number to 10, then it's doing modulo 10. So that means before, whatever record was going maybe to, if the record was going to partition, let's say 0, 1, 2, 3 partitions, if the record was coming into 0 before, now that I have 10 partitions, like 0, 1, 2, 3, 4, 5. So if the record was coming to partition 0 with the 3 partitions, now maybe it's coming to partition 2, right? So if the consumer was consuming on 0 before, now this is something that it's not going to know because the record is going to a different partition. You have to be careful about this. So, and you don't want to handle that in your consumer code. I mean, you could handle the logic in your consumer code, but you want to be careful. So this is where we're talking about this right here. I have 2 partitions. I can only have 2 consumers, 1, 2. 1 consumer to a partition. I cannot scale. If I add a 3rd consumer, it just does nothing. Then someone comes to go, hey, wait a second. I went to Kafka training and we need to increase the number of partitions so we can scale partitions for scalability. So yes, that's true. But then now when you increase the number of partitions, notice the yellow circles will go into partition, to this first partition before consumer 1. But now all these yellow circles are now going to the 3rd consumer, and consumer 1 is now getting the squares that it wasn't getting before, and is also getting these, so there's a change in this because of the change of the formula. So you just have to be careful with that. How are consumers notified partition changes? You see again, the rebalance actually. So when you have whenever the number of partition changes or new consumer enters or leaves the group, then a rebalance occurs. And then, of course, that's like the fire drill. But if that consumer was consuming before 0, if it still had the consumer that was assigned to 0, if it was consuming only circles, as in this case, now it's getting different. As long as you can handle it in your consumer code, that should be okay. But that's a lot of work. So the better thing to do, instead of doing it this way, what we recommend, this is the recommended best practice that we tell customer. So KSQL DB makes it really simple. If I have an old topic that has like 3 partitions, I can just create a stream on that topic. Say create stream, let's say old stream, and specify the data where the topic, that has the 3 partitions. And then I now have a stream of data from that topic. And then I can say create stream, new stream, and for the new topic, right? And what's going to go into this new stream is the select star from old. So select all the data from the old topic and just send it to the new topic. And then all you have to do for the consumers now is just tell them, hey, go ahead and consume the data from this new topic. So if the topic was, if they were going to topic A before, then now you can just tell them to go to topic B. Simple change for your consumers. And you see now I have 12 partitions or whatever, 20 or whatever number of partitions you want. So KSQL makes it super easy to migrate the data from an old topic to a new topic, which is a recommended way to do this. And then you just point all your consumers to send out note to your developers. Say, hey guys, here's the new topic. Go ahead and please start to consume from this. Okay. So this is really the recommended way to go. To create a new topic with the however number of partitions you want. Maybe you decided, hey, this new topic needs 30 partitions. And then you just point all your consumers to this new topic. And then this one says, can you think of situations where the hash of key modulo number of partitions might not be the most appropriate partitioning strategy in this case? Can you guys think of one? And the reason for this is, imagine that you have, let's say it's Christmas time, right? Or a certain time of the year where maybe there's a item that is, people are shopping a lot, and maybe you have a purchases topic. And this purchases topic now, or you have some hot key, some hot item, right? And you have a tremendous amount of requests for this item. So then, of course, hash of the key, because the key, there's a tremendous amount of requests for this key, then it's always the same, and then it will be skewed, right? In that case, because when you do a hash of the key, you see the key so many times because people are requesting the same item, and then hash of the key, modulo number of partitions. So let's say it keeps on sending it, let's say to partition one, partition one, partition one. But then now partition one has maybe 3 to 4, 5 times more data than all the other partitions. And we know that a broker will hold, if this broker, the entire partition, like if this broker here has partition 0 and this broker has partition 1, all data in partition 1 is going to be on the same broker. But then now you may have sort of like a hotspot, right? Because you have, whenever you need data from that. So it does skew it where now it's sort of like unbalanced, right? So you want to be careful with that. And then, like I said, when the key is not so a lot of those situations. And also, that's a perfect gang. That one is also really important, actually. The important thing is, that's a very good point, actually. Let me talk about that, what Gang mentioned. In other words, if you use a simple key, let's say I'm using a simple key like user 1. When you do a hash of this, sometimes you don't get a very good hash. And so sometimes it's not going to be distributed across the partitions the way you probably think it will be. And you may end up having a lot of this come to, even if I have user 2, you may have a lot of the user coming to the same directory and not even using all the other partitions well. So when you create a key, you may have to create what's called a composite key or compound key. Some people say compound. If you create a composite key or compound key, so let's say I take a user ID, and maybe I combine that with some other kind of department number or something else, and maybe also some kind of special, who knows, last 4 digits of something. And I have a really good, unique thing, then my hash is going to be better, and it will be distributed better across the cluster. So when you design your key, when you choose your key, right, you want to make sure you have a good, a really good choice of the key, right? Use a compound or composite key so that you can get a good hash distribution. And that's what I think Gang and Shirley, both of you guys, your hints are pretty much towards this. So choose a really good key. Now, the other thing you could do is say, well, I want to build my own custom partitioner because I know I'm going to expect a certain number. Maybe it's doing holidays, so I know that this item is hot, and I want to, whenever I see this key, I want to send it to some other partition because I know it's going to be special processing. I can create my own custom partitioner. So in Kafka, we have a partitional interface. And remember, in Java, this is how we handle multiple inheritance. If you have an interface, then you need to implement the interface, right? And if you implement the interface, then you have to define the methods. So this interface this partitioner interface in Kafka has these methods. What we're really concerned with is this partition method. See how it takes a topic name, a key, serialized key, a value, serialized value, and then a cluster metadata. So we need to implement the partitioner interface and define the method so that we can create our own custom key. Custom partitioner, sorry, not custom key, custom partitioner. And here's an example. So in this case, I say public class, I call it my partitioner, call it whatever you want. It implements the partitioner interface. So that means now I have to define the methods. I have these methods, but here's the one that we want to focus on. There's the partition method, which takes the name of a topic, the key, a serialized key, the value, serialized value, and then this cluster metadata. Okay. And so then I say, look, I use the cluster metadata to get the partitions for, so give me the number of partitions in this topic, and I get the number of partitions here. And then I can then check, like, say if my key bytes equals null, or if the key instance of string, but because I have a not, so if there's not a string, then I can say throw invalid, this does not have a string, right? But if the string, right, is equal, I cast the key to the string. But if it's equal to whatever I'm looking for, like the hot item, then return 0. What that means is actually send it to partition 0. Then for all other records, right, do the number hash module number of partitions. So in other words, for all the other records, do the regular hash algorithm on it. But for this one, send it to partition 0. So in other words, whenever I see this key, send it to partition 0. For everything else, send it here to wherever you want it to go. So this is called your own custom partitioner that you're creating, right? You're creating your own custom partitioner. And this one is using if you don't want to create your own class, you can just hard code it. Like in this example, I say, look, I'm specifying right to this topic, right to this partition 0, and here's my key, and here's my value. So it writes the message to partition 0. So if it says, which one would you want to do? Yang says, cluster.partition variable, is this from the metadata received? Yes. So this, in other words, let's come back to this. This gives you access to, I don't remember all the detail, but it gives you access to the information about the partitions, the topics, and all that kind of stuff. And then when we say partitions for, right, we can get the particular topic. So, and yeah, I have to look at the detail to see all of the things that it gives you. But in this case, yes, you get the metadata for this topic, sort of like what you do get back when you're communicating with the brokers. But it gives you access to this, to the metadata. And then this one, so which one do you prefer? Well, hey, this is perfectly fine, but I prefer the class, because if you create a class, then you can just tell all your developer, hey, when you're processing, use this partitioner, then it's much easier for people to just use it instead of hard coding it, because this can lead to a lot of inconsistency in your environment, right? If you allow your developers to do this kind of stuff, you have a really unbalanced cluster, most likely. People will be writing to any kind of writing everywhere. So be careful with that. And then now we come to sort of the overview. There's a KSQL DB, Kafka Streams, or Kafka Connect, SMT, single message transform. When do we use it? Just to let you know, start with KSQL DB to begin with. If you don't use Java Scala, you need to Kafka, or if you prefer the UI or REST API, right? If you start with Kafka Streams, if you do use Java Scala, if you want to tight control over performance, or you just prefer deployment flexibility using Java library, all of these things. So these are reasons why you start with one versus the other, KSQL DB versus Kafka, right? And then what about single message transforms? In single message transform, when you talk about this, right, it's good to use at any point. Remember, I can filter the data before the data get into Kafka, right? This is a great thing. So if you have administrators, if you have DevOps, if you're not a developer, but you still want to do some great work, can filter data, mask a field, drop a column, whatever you want to do the single message transforms before. And then if you're a developer already and you don't care to learn this configuration, then it doesn't matter. You just, when it's in Kafka already, you just write a simple Kafka Streams application, do a filter, map, whatever you want to do, and then produce your output back to Kafka. And then you can do whatever you want to do at that point. Yeah. And then now authenticating to a secure cluster. When you talk about security, right? One of the things you want to know in industry is like the CIA. This is not about the spy agency in America, right? But when you think about security, you want to think about these principles: confidentiality, integrity, and availability. So in other words, whenever you're in any environment and you're trying to protect that environment, you want to say, how do I protect everything so that we do not lose confidentiality? And you say, well, what is confidentiality? That means if anyone sees or have access to information that they're not supposed to see. So for example, if even an administrator runs a query and they can see the financial transactions and they're not supposed to be able to see that because they don't have the clearance to do that, then that's a loss of confidentiality. It's like saying I have a piece of paper on my desk and someone comes in and see, oops, they see the note on the paper. Well, they're not supposed to see that. That's a loss of confidentiality. And then integrity is RT library. Oh, okay. I was about to ask. Integrity is when anything changes about the data, right? So even if it's accidental or intentional, that's loss of integrity. So there's a salary information on the desk, and I see that, okay, I see my name and I want to add a 0 to my salary. Well, that 1 0 has changed. That's a loss of integrity. So if anything changes about the data, whether accidental or intentional, you have lost integrity and it's not a good thing. So you want to protect your environment from that. And then availability. You want to make sure that you do not have some denial of service, whether it's done on purpose or accidental. So your environment needs to be fault tolerant and secure, all of that kind of stuff to protect from hackers, or to do all those kinds of things, because you want to make sure that you do not lose availability, right? So those are the basic tenets of information security that you should think about when you are talking about security to begin with. Always have those in mind. Then when you look at the framework, you look at Kafka, you say, well, in Kafka, how do we protect against this? Well, we have authentication things that we can do with role-based access, SSL, and SASL. Authentication is proving who you are. For example, if I say, hey, show me your ID, prove that you are Eric, and Eric shows me his ID, shows me, and I say, okay, verify. Eric has proven who he is. Or like logging into the system, give your username and password. Now check, you've authenticated yourself, right? But imagine if you log in and you try to do a reboot and it says permission denied. Why? Because you are not authorized. So authorization is what you are allowed to do, right? That's authorization, what you're allowed to do. And in Confluent, we have role-based access control and ACLs, access control list. So, and then we also want to protect the data when the data is going across the network. So we want to protect, like this is in SSL, we want to protect, so we want to encrypt the data, but we call it TLS, transport layer security is the newer form. So you want to protect the data when the data is in transit. So think about these are the things we have. And this part, we don't really teach you security in this class, but we just, it's a basic overview to know that, hey, if you're doing SSL, you have to understand how certificates work, stuff like that. What is a certificate authority? What is the web of trust? How do you create the certificate sign and request? How do you send it to the certificate authority to sign? The cert authority. to sign that? Where is the certificate going to be stored? And then once you know all that kind of stuff in Kafka, you see that, the trust store, and it says, look, here's my trust store, here's my password to it, and the security protocols here. And in this case, you can do, in other words, have a situation where the broker is authenticating to the client, or you can have mutual SSL where the client also authenticates to the broker as well. So you can have one way or two way when you're dealing with SSL. But this does not tell you how to do anything. It's just saying, look, in Kafka, we can do mutual authentication. And then for SASO, this one says SASO, Simple Authentication and Security Layer Handshake. Are you guys familiar with this one? SASO? It is not the dance. Okay. Well, when it says Simple Authentication and Security Layer Handshake, I'll give you a really simple explanation for it. Imagine this. It's a relationship. It's like a handshake, an agreement between the client and server. So let's say this is the SASO server. This is the server here. I'll say server. And this is SASO, S-A-S-O. Well, let's just say this is the SASO. And imagine you're at a dinner party and these are the trays, 1, 2. And imagine that you have peanuts here and you have apples here and you have crackers here. And now this is Martin at the dinner party. And Martin says, hey, I want to grab some peanuts. But the SASA server says, okay, there's a protocol you have to follow. If you want to eat peanuts here, you have to pass the authentication. See how it says Simple Authentication and Security Layer Handshake? You have to pass the test. So the server is going to send you some peanut dust. And if you do not blow up with allergies, then yes, you pass the test. So in other words, you have to be built to handle the challenge, right? And then you can say, okay, great. Now I'm doing SASA, peanuts. But of course, this is silly. You say, okay, Hussein, what does this have to do with Kafka? Well, when you're doing SASA, the choices you have here to use is not peanuts and apple. So you may not be able to do, well, actually, in this case, you will not be able to do SASA peanuts because you fail the challenge. So you cannot do SASA peanuts. But you can say, well, that didn't work because I failed the challenge. I blew up. But well, what if I try apple? And then you get a little bits of apple dust. And then, ching, yes, it does work for the apple. So you can do SASA apple. But like I said, this is really silly example. So now let me change this picture and let's change this here. Okay, so we forget about peanuts and apples. And we'll say when you're using SASA, you have a lot of different choices. You have SCRAM, Simple Challenge Response Authentication Mechanism. You have Kerberos. You have Plain. You have OR. So now the client here and the server say, okay, choose your poison. Which one do you want to authenticate? Which one do you want to use to authenticate? So let's say this client says, hey, I want to do Kerberos. Then the server now has to challenge the client. The server is going to challenge the client and say, hey, I'm going to see if you're built to handle this. This client has to be built to handle it. That means the client needs to understand the GSS API, the General Security Services API, right? And so if the client was developed where it understands the GSS API, then this client will pass check to say, yep, if you understand this, then yes, you can do Kerberos. So that means it becomes SASA, Kerberos, Kerberos, or you see underscore GSS API like this, SASA underscore GSS API. That means the client has passed that because not all clients can do Kerberos. For example, in a network environment, if I have NFS version 3, NFS version 3 cannot do Kerberos, but NFS version 4, NFS 4 understands Kerberos. Why? Because it's built with the GSS API. So that's what SASA is when it says Simple Authentication Security Layer Handshake. The client has multiple means to try to authenticate itself, but it needs to be able to pass the challenge. And if it does, then it can agree the server and client agrees on the mechanism, and then they're good to go, right? And this is something to keep in mind. And that brings us to this point. But instead of stopping here, what I'm going to do is just give you guys a quick tour, and then we will almost be at the wrap up point, because we are now at Confluent Cloud. The whole point of the cloud is just to let you guys know that, look, it's fully managed. We can do fully managed for you, right? And authentic, we'll talk about this. It's just a real short chapter. So you can see it here, Confluent Platform. We have self-managed software or fully managed. You can manage in the cloud. These are different ways. So if you manage it yourself, you can run it in Kubernetes. You can run it, of course, Kubernetes manages containers. And if you're running in Docker containers, then you can, of course, be managed by Kubernetes. You can run it in virtual machines. You can run on physical hardware, right? You could run it in the cloud, whether you're doing AWS or Google Cloud Platform or Microsoft Azure. And you can also, again, you deploy on-premise in your own company, or you can deploy in the cloud. The fully managed one is we manage everything for you, right? Is Apache Kafka re-engineer for the cloud. Really powerful. You don't have to worry about a lot of the administrative concepts, a lot of the you just say, look, this is the performance I want. This is how many, and we just take care of it for you. It's really amazing. So fully managed streaming platform, right? Managed by web UI, automate by command line. All communication between users in Confluent Cloud is secure using TLS, encryption, transport layer security, right? Very powerful. And then you also, they say, what does fully managed mean? Do stuff like this: provision, install Kafka, broker, instance sizing, cluster expansion with auto data balancing. We also have something now called self-balancing cluster, which is really amazing. See, because before, let's say if you had Kafka and you add a new node to Kafka, like a new broker, in the past, Kafka would not move partitions to that new broker. In the past, that would not happen automatically. Now with the self-balancing cluster, if I add a new node to Kafka, Kafka will automatically move partitions around to give that new node some data, which is awesome, right? So self-balancing cluster is also a feature in the cloud in our enterprise service. And also we have stuff like what they call cluster linking. Lots of really nice feature that we don't have here in this document right now. We have connectors, KSQLDB, schema registry, uptime monitoring, 24/7 support with committer-driven expertise, uptime, service level agreements on infrastructure and software, bug fixes. So we give you a lot if you come to us for fully managed, right? And then in this one here, it's a Confluent Cloud web interface. It looks pretty much like the Confluent Control Center, as you can see here. It looks very similar to what you guys are already using, like the Confluent Control Center. So the web interface in the cloud, when you go to our cloud, it will look very familiar to you because it's just like what you are familiar with, okay? And really easy to use. And then you can see a lot of different things in the cloud, you know, when you connect replicator. Replicator is something that can replicate data between two different colos. Like I could go from here, replicate the data here, and then replicate the data from year to year, right? Confluent Replicator is really powerful. You can view the consumers, like the lag time. Let's say in the log, you remember if you have a log, the consumers are processing the log. You can view, let's say if the consumer is here, here's the consumer, but the end of the log is here. So the time between this time and this is the lag where the end of the log is and where the consumer is, because the consumer is behind in messages. So this consumer is a couple of messages behind, like 2 or 3 messages behind, because the end of log is, let's say you're at 5 and the consumer is at 2. So the lag time here is the number of messages between. So that's like 3 messages behind, because it's where they call the end of log, EOL. So a lag is from where the consumer is to where the end of log is. But you can view all that kind of stuff in consumer cloud in the cloud. And then to connect to the cloud is actually pretty simple too. Just like going to Amazon or anywhere else, we give you your credentials and everything else. And you have to be able to notice, like say, bootstrap server, security protocol, password. So it's the standard kind of thing that most people are familiar with today. And so to connect, we give you good documentation. It's really easy. You probably spend about 30 minutes when you first start to do this to be comfortable with it, but that's it. And then we do provide a C Cloud command that you can install on your local system. So I can install this on my local system and connect to my cloud environment, right? So I have this running on my laptop right now, and I can connect to my cloud instance when I want to, right? I could do C Cloud login, give my email password, and then I log in. And then I can say C Cloud to list all the different environments. Because it's a cloud environment, you'll see a lot of the different environments that are available. Like when you go to GitHub, you can see all the different things there. But then I can decide what cluster. I can say C Cloud Kafka cluster list to list the particular clusters that are available. See, I say like here, name, the provider's GCP. It's in Europe West, and I get this. And then if I want to use a particular cluster, as long as I have access to it, I say C Cloud use and give the cluster ID. So then I will be able to then connect to that cluster. And then once I'm on that cluster now, that Kafka cluster, look at the commands are very simple. I say C Cloud Kafka topic list. That's just like a separate command, separate arguments, sorry, not command, but I can list the topics. And then I could describe the topics just like we saw with the Kafka topics command, but I say C Cloud. And then I could say, if I want to create, I could say C Cloud Kafka topic create, a topic name, and replication factor 3, partition 6. And then I'll be able to list the topic and see it. Very, very easy to use in the cloud. And that brings us to this point where we say, whoa. So after this, you want to know what fully managed and what self-managed, and this is a basic introduction. But now, as I promised before, what I'm going to do is take you guys for a quick tour of this thing. It will just be really quick, and you'll see that very powerful places to look at, as I mentioned before. So let me share this screen real quick so that I can show you that. And then we will take it from there. Let's go here. Oops, share screen. Just a second. Okay, there we go. And then now, oh, I say a question. The Connect replicator, those Connect workers are fully managed as well. Replicator, yeah, yes. In the case of Connect, if you have actually, I guess I have to understand the question carefully. If you're using an enterprise, you have access to Replicator, right? And I think you will have to replicate your data, but you do have access to it. That's a good question. I don't know if they do it for you automatically, if that is your question. But you do have access to move the data around. And now the first place I want to show you guys is this. Yeah, since it's okay. Yeah. So the first place I want to go is go to this kafka.apache.org. And I will send you guys a document that has all of these links, right? Okay. So in this case, when I get to kafka.apache.org, I want you to look at this. See how it says download Kafka? And again, I have a document that I will send you guys at the end of the class. So I know we're almost towards the end, so please bear with me just a second. I go to download Kafka. And look at this. When I say download Kafka, you can see here, this is the first place that I came to start. This is the latest release. Pretty soon we'll have like 3.0 coming out. But notice that I can get the source code. So number one, notice it says Scala, and you see the 2.12, and you can see the name Kafka 2.12. It gives you the Scala release as part of the source code. And then I can click, so you can literally just click, and this is the TGZ tells you it's a tar and tar compressed format. like tar gzip or tar gz. So it's a tar compressed format, and you can have different versions. So you could just click on this, and right away you will start to download the source code to your system, right? If you pick one of the locations close to you, and then once you do that, as you can see, I'm downloading this. And once you download this, you can open it up in your IDE, whether you use IntelliJ or Microsoft Visual Studio, or even if you use VIM, right? VI improved. You can be able to search the code, use regular expressions, find command to search, and search for different methods. So that's one of the first things to let you know. So as a developer, you have access to the source code. So that's part one. The second thing is the docs. If I come to APIs, right? When I click on APIs, notice that I can choose the latest one. But if I look on the left-hand side here, see I say producer API, consumer API, streams API. So I click on the producer API, for example. When I click on producer API, notice it says producer API allows applications to send streams of data. And here are the Java docs for it. And this is the Maven dependency. So if I click on Java docs, yeah, I then end up at in the Java docs for it. And I can see all of this. I can look at the index, click up here with index for all of this, or I can just come over here and look at the tree view for everything, and you see all the different classes. Or you could just, I like to click on all classes and just have it like this, all classes. And then I could just do a Command F and search for like Kafka, let's say producer. When I search for Kafka producer, I see something like this. Click on Kafka producer, and here is the document. So when we talk about the Kafka producer, you can see here, I say, here's again, notice implemented interfaces, and then I say public class Kafka producer extends the object, implements the producer, and then notice a sample code to tell you it's thread safe, and here's a sample producer code right there. And then if I go further down, it gives me lots of details like things we talked about in this class. And then here's the transactional API. This is showing you sample producer code doing transactions. Notice how it has beginning transactions, producer.init transactions, then producer begin transactions, producer fence exception, out of order sequence exception that you can catch. And then it shows you, and then abort transaction, whether you abort the transaction or whether you commit the transaction. So it shows you a little bit of the code, and then it gives you a lot more detail. So you can see the same thing for all classes, whether you go to producer API, consumer API, you'll see all the Java docs here. So, okay, so this is number 2. And now I'm going to go to number 3, and we're almost done. Sorry about that. I'll just type KIP for now. And remember, I have this in a documentation. I'll just say KIP and Kafka. Okay, so I click on Kafka improvement proposals. I do have these links in the documentation for you. And when you come to the Kafka improvement proposal page, you'll see this coming up in just a second. Yeah. This is the one that I mentioned before, which is like the what you call the RFCs, request for comments. On this page, you'll see it talks about the purpose, what is considered major change, what would be in it, and it goes on to, now if I come down here, Kafka improvement proposal, notice all the KIPs, these are the different numbers. Notice if it says WIP, that's a work in process, and I go, so for example, you can scroll down, you see there's so many of them, right? Now let's go, I did promise you guys to talk about the EOS or ticket. So if I go command and I say exactly, let's see, exactly once, and let's say enter. So look at this. This is KIP 98. It's an older one. It's exactly once delivery and transactional messaging. And when I click on that, right? And you can see it was added in Kafka 0.11. So just this one document about EOS, but you'll see how all the details here. Notice what it takes you to, the discussion thread, right? So if you really want to be involved, go there. And yes, the Jira, or Jira, some people say Jira. And you can go and look at what was happening, look at the motivation for it to get more detail, and then a little bit about transactions and streams where they'll tell you. And then you can see the public interfaces and API where they tell you, so the producer would get 5 new methods, right? That means without transactions, it didn't have these, but this init transactions, begin transactions, send offsets, commit transactions, abort transactions, right? So there's 5 new methods with the send method update, and it goes on to throw a new exception, and it shows you a sample of the code. As you can see, init transactions, begin transactions, it shows you a sample of the code, which is excellent. And then if you go further down, as we keep on going, look at the new broker configurations. Broker has this concept, some of the things that we didn't talk about, but you can see all levels of details that you will not find in most documentation. You'll find in this KIP, right? In the documentation, we only talk about transaction, state, topic, but you can see a lot more details for all of this. And then producer configs, we talk about enable idempotence, we talk about transactional ID, but I didn't talk about transaction timeout milliseconds. See, the maximum amount of time in milliseconds, transaction coordinator will wait for the transaction status and goes on and on. Default is here. But the whole point is you get this, and then consumer config, we did mention isolation level, but then it tells you all about that. And then the proposed changes goes further down. And then now look at this. It also gives you a little bit of an idea of here. This is like an example of a Kafka Streams application. See consumer, producer. So this is like a Kafka Streams application. See how it's communicating with the consumer, with the group coordinator, with the transaction coordinator, and the brokers. And so it takes you through this description of sort of like what we had in the document, in the course. But it walks you through the step-by-step as well. And then you can keep on going. I won't keep on going, but as you can see, lots of stuff. And if you go all the way to the bottom, as you can see, a lot of information. And if that is not enough, then look at this part. It says the design document is available here, right? So click on the available here, you will actually see more with the design document. And when I click on this link, look at this, exactly once delivery and transactional messaging Kafka. And then look at this design document. How many pages? And I won't go through these pages, but I'm just going to go all the way down here to see how many pages is here in the design document. There's a lot of pages, okay? It's still going, and you can get more detail. So, but the whole point to this is any feature that is in Kafka that you want to understand and you want to look and know about in more detail, you can find in the KIP, Kafka Improvement Proposals. All you have to do is come to the main page, KIP, and then you can search for it. And then, for example, one thing that will be coming up in Kafka 2.8, for example, we are going to get rid of Zookeeper, right? So there's a KIP called KIP 500. So if I do a command F and say KIP 500, for example, okay. Actually, I can just go down here and just scroll down here. But you could just search for Zookeeper too. But here's the 500. See here, replace Zookeeper with self-managed metadata quorum. So now you could, if you want to find out this detail, right? Even though we didn't talk about this in the course, I can come over here and realize to talk about the motivation, currently how we use Zookeeper to store all the data about Kafka. I mean, all the metadata, everything about the brokers we stored in Zookeeper. And we talk about that. But then what is it that we're trying to do now? Well, we're going to move this into Kafka where we will not be using Zookeeper. So in Apache Kafka 2.8, we now have these controllers that we use, right? And it tells you the details about it here, where we have a controller quorum. We have like 3 controllers that we will use. And this is an important point. We use this algorithm, the raft algorithm, to ensure that, the controller node will, allow them to elect the leaders and do all the things they need to do. But the whole point is this document describes all that level of detail that you don't see in the course. But if it's in Kafka, it's in this document, it's in the KIP. So if you want that level of detail, you have the source code. That's the first place I showed you. You have the KIP, you have the API, and then the last part, this is the fun part, and then I'm done. If I go to blog.confluent.io. And as I mentioned before, I have all of this listed in a document. I will send them out to you guys. When I come to blog.confluent.io, I come to categories. And in the categories, I can search. So if I'm curious about streams or whatever else, I have some great topics. Let's say I want to do something about Kafka streams or something like that, right? I can look and say streams processing, click on streams processing. Then it pulls up all the articles, right? Overwhelm. And the last part is the GitHub. So Confluent, this is the last one, GitHub. And you guys will have this in your documentation. But in the GitHub Inc., as you guys come here, you will also find source code for everything that you want, like KSQL, Kafka Streams examples, Kafka, the REST API, CP demo. You'll find a lot of the stuff that you have access to. So just go to GitHub, and you won't have access to everything, but the obvious ones you'll be able to access in GitHub. So with that, ladies and gentlemen, the last thing I need to just ask you to do now, and then I will stay around and answer any questions, is I want to give you this code for the class, which, of course, if you guys don't do it, then you really say, huh, Hussein, we really hate your class. And so we're not doing a survey. But if you if you could take just a couple minutes, and I know it's a long day, but let me just come over here and give you this code for the class so that you can do it. So the class ID that you would need to fill out the survey is right here. And oops, let's just make sure that you have this. Yeah, this is right. This is Iris. Okay, I have the right class. Here's the class ID that is in chat, 2859. And the site that you have to go to do it is the same site where you logged in originally. And then, if I go to http://cnfl.io/cr, remember, this is where you guys log in to begin with to get into your account. When you log in, and you guys have been logging in, so in the left-hand corner, you go to your classes. And then once you get to your classes, as you did before, right? So it's just like how you logged in from day one. Log in, and then the class that is in progress, you will have to come to the bottom where you say view, as I'm doing here on the screen. And then once you view this, it's the last part on the line where it says, on the course completion, this is the Confluent training survey. And then you guys will be able to click that survey and then answer the questions. And make sure, please select the name, like I am Campbell Hussein, and then give the class ID, and then, and then you just go through this process. So with that in mind, ladies and gentlemen, I really wish you guys a lot of success in your work and in your life. And maybe one day when I'm in Singapore, we can all meet up and have some good food. Okay. So just know that there are exams. If you decide to take the exam, you will be able to spend $150 for the exam. I will send you out some sample questions for the exam. Thank you, Tate. Thank you, Gangling. Thank you guys very much. I will send you guys some sample questions for the exam. And I will send you some, like I said, expect to receive a Google Doc from me. I would say you should get it by tomorrow. I'll send it out to each of you. Absolutely. Thank you very much, guys. I hope you had fun. Remember, the details you'll see in the documentation. So if you could just remember it and play with it, and you can get added details from the documentation, you are going to feel good. Thank you, guys. Thank you very much. I'm glad that you enjoyed it. It's hard to tell when my audience is a little bit quiet, but I know everyone's working from home. And so I really appreciate it. Thank you very much. I'm reading comments. But please take a couple minutes and do the survey. That way they know that I actually worked this week and I wasn't sitting on the beach somewhere. So appreciate it. Okay. Shilling, thank you very much. You are going to be our resident expert. So everyone, you guys know who to contact now. Shilling Wu. He said, I will be contacting you I'm pretty sure. Okay, awesome. The course ID is this 2859. 2859. So 2859. Let me write it again. So class 2859. There we go. Yep. So I will mute myself for now, and I will give it another 15 minutes, so just in case anyone has any questions, and then we'll take it from there. Okay. And then I'll end the session. So thank you guys so much. Good luck, and look forward to the email from me. I will send an email out to all of you. Okay. Really appreciate it. Great class, good questions, and fun group. Awesome. Yes, you can email me. Absolutely. I do answer questions from students. Sometimes it may not happen right away, but because, if I'm teaching, but I will definitely get back to you with it. Yep. Oh yeah, if you're behind on the lab, no problem. And you'll see the labs are actually written pretty well, so you'll be able to go through all of it without a problem. And that's good. But if you have questions, don't hesitate. Yes, the labs are really nice, and you can modify those labs and do your, do your own stuff that you want to do. That would be great. Excellent. Thank you, Precious. Thank you very much. I try to use simple examples because, you can always get as complicated as you want when you look at the API. So my goal when I teach is to actually keep it as simple as possible.